Welcome back to the Automation Podcast, the world's number one industrial automation product and technology show, thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, if you're brand new to the show, my name is Shawn from Insights in Automation, and each week I invite a new vendor to come on the show to talk products and technologies. And this week I have a gentleman who started an MES company on the show to talk about what his company, the solution he has and the problems that he solves that many of the very large MES companies just can't do affordably. So I think you guys will enjoy this, and you'll also probably notice, if you're a regular, that the podcast has been released a day early. I like to do this during Thanksgiving week so that you can listen to it on Wednesday if that's your final commute of the week, instead of Thursday, which everybody's busy, typically here in the U.S., busy with turkey and family and sitting down to a nice meal. So I hope you get to enjoy that if you're one of our listeners in the U.S. So with that said, let me jump into our sponsor's message, and I'm actually sponsoring this myself. So if you know anybody who needs PLC, HMI, or SCADA training, please tell them about theautomationschool.com. If you're one of my students in an Allen Bradley PLC or PAC course, you're going to notice I just added some new lessons to every PLC course. And the reason I did that was because I wanted to update all the students on what is, as of late 2024, the pricing of the paid software, what's available for free trials. I wanted to let you know about some of the simulation packages we're using here in-house that I really think you guys will like, including our own free PLC simulator, which I paid somebody to make and I now give away free to my students, as well as Factory IO and Logic Designs PLC Logic. So check out lesson 102, and I'm about to drop update to lesson 105, 106, and 107. So if you're a student, check those out. Just trying to give you guys more options to save money, because not everybody can go out and spend 10 grand on software and hardware to learn PLCs or PACs. So everything from our free option, the PLC application simulator, to the lower cost options of Factory IO and PLC Logics. I think you guys will like those. And of course, we sell those two packages at theautomationschool.com. So with that, let's go ahead and jump into our show. And if you don't mind, Ryan, could you please introduce yourself to our audience?
Thank you so much for having me on today. Appreciate your time, and I'll do my best to not go into weird rabbit holes and boring sections on MES, which is easily done. But my background, I grew up in the Midwest in a small manufacturing town in Illinois. Kind of always been into making things. Got into cars very early. Went to school for mechanical engineering and entered the automotive industry. So in 2000, I took my first role with General Motors. Spent 10 years in GM, a couple years at Tesla in their early days, launching the Model S and building out the Fremont supporting structures in their factory. Did a tangent into a software company for a couple years doing cylinder deactivation controls for gasoline engines, which is pretty cool. And then I had a chance to run a motorcycle factory for 3.5 years. So largely automotive, and then I think, bigger company down to smaller company, the two themes, all the way to the point of starting one. And we formed Pico because, frankly, we were just sick of using really poorly designed and laid out software that wasn't up to modern expectations. It's the third time that I've been involved in building an MES, and hopefully the last. So I would very much not like to do this again. So I would not recommend starting a company unless you absolutely need the product to exist on the other side. So
it is a big undertaking. And, you were talking and I was like, my Dodge Charger has the cylinder deactivation.
yeah.
And I'll tell you, when it goes into eco mode and shuts down half the cylinders, I never even hear it. I'm getting older now, but I've had it for 15 years. I never hear it and I never notice it. So that is some excellent technology. So I just wanted to throw it out there.
We were working on the level beyond. It's the individual cylinders. We shut them down one at a time instead of 8 to 4. But anyway, yes, neat stuff.
Yeah. So they say don't call it a semi-hemi, so I won't. If anybody remembers the funny commercial from way back then. But in any case, so MES, now I think all of the audience understands what a manufacturing execution system is. But from your standpoint, as somebody who actually ran a factory, right? Tell us what MES means to you.
But before we get into that, I wanted to thank those of you who signed up in our new membership program either on YouTube or at theautomationblog.com. In appreciation of your support, you get exclusive access to the videos of episodes that are not sponsored by the vendor. Now, to learn more about our membership program, which is only $10 a month, please visit theautomationblog.com/memberships. And with that, let's go ahead and jump back into this week's episode.
So there's a couple of camps out there, and we can the formal definition of MES is the command and control layer. So if you're curious, you can look up a spec called ISA 95, and it lays out ERP on the top, MES, SCADA, PLC, sensor levels. There's a lot of issues with that pyramid in how the systems come together. The theory is correct in the fact that like all these things have to play nice. The new camp is unified namespace. I'm sure you've gotten into that or in your world, but the MES has classically been receiving orders of what to build, structuring when those orders are going to hit the shop floor, so sequencing and optimizing for that, routing, and then governing that the work is performed correctly as far as the source of truth or historian of the data, either back to the ERP or to hold in its entirety. So the command and control layer is the easy way to say it. The problem with that is it forces you to have to integrate everything. And especially when you start with, depending on the legacy system of choice, I mean, a lot of automation systems have been around since the 80s and 90s. You get into ERPs, they're just as old. The integration of these systems can be a challenge, to say the least. So we have a slightly different take on MES. We violate the southern boundaries of the ISA 95 stack and get down to, we can take in a $2 micro switch as an input through one of our edge devices. We have, I wouldn't call them SCADA functionalities because there's no safety component, but the ability to govern work or data and move it across stations. So you have some of the transmission values. We can talk directly to PLCs. Our theory is that you need to take what's supposed to happen. So think it is like, work instructions in its rawest form and tie it to the things that are doing the work. So tools, people, machines, so that you can collect the data that matters, which drives insight and value on the other sides, right? There's value along the way, training, error proofing, first pass yield improvements, but where the real value comes in this kind of industry 4.0, call it whatever BS term you want, is when you can generate, oh, crap, if these two things occur, this problem happens. We should probably fix those. How do we fix those? Oh, we're applying too much epoxy. Put a scale underneath it, measure how much came out. Hey, now we're in range. We're good to go. Problem goes away. You never see it again, whatever it might be. We shoot bolts. Use a DC nut runner or just a clutch tool with a feedback loop so it says how many you shot. Now you don't have to worry about one of them being not present. It's the ability to say this is what was supposed to happen and then make sure that it did.
Yeah, I remember back in, I think it was the very late 90s, early 2000s, Rockwell was getting us all trained up on SP95. And that's when it was still a proposed spec or I just remember the slides with all the different octagons on it. And MES was made up of all these different pieces. We had data collection, historian, we had analytics, we had X, Y, and Z. I think there were 11 or 13 of these little boxes, and it's evolved over time quite a bit. And I think for a lot of the people who are on the plant floor, they have these, I hate to say this is going to be like buzzword bingo. I hate to say islands of automation, right?
Ooh,
but in many cases, yeah, and a lot of times they try to glue it together with their SCADA system or the historian, but that just doesn't get you to the layer of MES, right? It doesn't. What we end up having is all these silos of data, these blobs of data that never get looked at, right? Well, maybe somebody looks at a trend, and if there was a problem, they may go back and manually look at it, right? And they may even have a condition and monitoring package that can see a deviation and give us an alarm. But what you're talking about is really taking the orders in from the front office and saying, make 10,000 of this, and then orchestrating that down. I believe, and correct me if I'm wrong, but taking that down to the plant floor and saying, okay, this is what we need to do to make this happen. You make so many of those, you make so many of those. I mean, but also tying into the historians, so you know that, hey, this is the data for that run. If I want to pull up this order, this production run, it knows where the historical data is, and it knows how to tie that in. Am I even close?
Yeah, I mean, there's hundreds of small functions that build all these systems. It's no different than any of the other layers, right? And they all have to work together. So in our world, in our definition or how we execute, we have things like process dependency checks, where when a part enters a station, you check to make sure that it has a valid complete flag from the station in front of it. Well, it can be a manually assembled station, like did they actually bolt it down? And we're looking at a minimum, did the operator signal that they completed the work? It could be, looking at physical measurements from tools that were associated with the work. It could be a $2 micro switch that just said, yeah, the part was in the fixture and now it's not. But something that says it did what it was supposed to do, and then we'll release it into the downstream. There's also a layer that says, you have the I did it, and then you have the what do I do next? So the what do I do next part of it is you ordered 5 bicycle frames of this configuration. So this station needs to produce 5 of these sub-assemblies, and it was different than the order before, and it's different than the order that'll follow. But how do they know which variation of the process to run? So we'll govern that with a parent-child relationship between the manufacturing order and the individual work ticket. And then you mentioned the historian. So that's a key piece, not only for the in-process movements in the quasi-SCADA world, but also just 6 months later when something goes wrong, you're trying to understand, did I build one of these bad? Did I build all of them bad? What changed? Sometimes you have all the information you need to make that decision. Sometimes it's in the supply base, but how do we integrate all of these things together against the idea of the product produced? It's an interesting challenge because classically MESs were all custom, right? They would live within a framework, and then you had to customize everything around it. And I think a lot of the problems was the systems they came off of weren't the right fundamental level framework. If you think about how automation works, it's not directly set up. It drives a lot of I/O. It has a logic system inside of it, but it's not thinking of the world as what's supposed to happen, where is it supposed to happen, and what did it do. You can try to configure it that way, but it's not its core. And an ERP is thinking about transacting material. Right? I have raw goods, and I'm going to convert them into finished goods, and there's a cost associated with it that the accounting side of it needs. Neither one of those is how the shop floor works. Right? So the shop floor works is I have things that I need to do over here, and it's a series of steps that get carried out in some form of sequence, similar in many ways to automation. But there's a physical world constraint, again similar, where I can't have the same device in 2 places at the same time. And I might have 5 stations that are all similar to each other that can carry out parallel work, but it's the physical world constraints, and you have to marry the two together and add an operator or an ID for the equipment that's carrying out the work. And now you can actually perform work. You can collect data. You can generate insights. You can create value. So it's a different framework, and I think by changing that framework, we can get out of a lot of the customization that has been in the past. And the customization is not bad. You want the system to line up to your factory. But if you're starting from a far way away and you have to do a lot of customization to get it there, it's really expensive. And that's the problem that people have seen. Right? Typical MES deployments are measured in months, if not years, to set up, and in hundreds of thousands or millions of dollars.
Yeah.
If you can switch that out and do this kind of bottoms up approach instead of a top down routing and hierarchical approach like the classic deploy, you can change the cost paradigm dramatically. You can build an element of work, you can copy it, you can tweak it, you can make variants of it, you can stack it into a workflow that creates products. I mean, the devil's in the details. It's fun to theorize about, but proof's in the pudding. We're an order of magnitude cheaper with the same capability, if not more, of classic MES. I mean, we ripped and replaced a Rockwell deployment in 6 weeks in a semi-truck factory. Right?
Nice.
Like, that was,
So that's a good point. Let's talk
yeah.
about that. So you can connect to, and let's just talk about this. So a lot of these manufacturing cells are automated, right? They may get loaded manually, but then they run, and then a lot of times they're unloaded manually as well.
Yep,
Sometimes there's material handling between the cells.
sure.
But if that automated system has a Rockwell or a Siemens PLC or somebody else's PLC, your system is capable of talking to those, right?
Hey everyone, I just wanted to jump in here and pay some bills. Thank you, first of all, for listening to this episode. And while today's vendor wasn't able to sponsor this episode, I still wanted to invest the time to bring it to you because I think you're like me. You like to learn about new products and technologies. So, with all that said, I'd like to ask you to consider becoming a member for just $10 a month, either on YouTube or at theautomationblog.com, to help me offset the cost of producing these episodes each week. In exchange for your membership, you will receive member-only perks and ad-free editions of every unsponsored episode of this show. With that said, thanks again for tuning in this week, and now we'll return you to this week's episode.
Yeah, through typically either direct, depending on the PLC and the licensing they have, so a tag read-write structure, or we have intermediaries. You can go through products like PTC is Cupware, where it kind of
Yeah,
does a
very
translation
familiar.
layer across all of these.
Yep.
Or you can go up to the SCADA layer, so Ignition being one of the more popular ones lately, where you can do things like an OPC UA
Mhm.
back and forth structure. So yeah, the big thing that Pico does different is we can connect to, you name the tool. There's 200 families of tools that we connect directly with, either through our little $65 microcontroller based edge device. So
Mhm.
I have a USB scan tool in my hand. How do I connect to that? Well,
Sure.
can't plug that into an Ethernet port, so I need something to gateway it into the system. That's what those edge devices are for. Serial converters are another great example. RS-230, 232 to be able to speak, pick your flavor of choice, Modbus across to an RS-485, things like that. You got to get it into the network if it doesn't have an Ethernet port sitting on it. So our ability to do that becomes really interesting. We can connect to torque tools. We can connect to scales. We can connect to laser engravers. I can connect to a PLC. I can connect to an ignition deployment for an automation system. It's trying to give people the opportunity to solve problems. Everything that we connect to was brought into the system to solve a problem. A data silo problem, a error proofing problem, whatever it might be, a speed up the system problem. But if you can connect to those different physical world entities, you can solve that. If all you have is a API structure on your edge and you force all that integration work onto the teams, now every single factory has to go repeat that integration. Well, that's not efficient. That's super annoying. You know how many people every day probably look at a DC torque tool spec and try to figure out how to talk open protocol to it? I mean, it's terrible. It shouldn't have to be that way. Like, how do we eliminate that repeated work? And in the
Well,
automation systems, it's really fun. There's a lot of things you can do.
Well, and that's why I was going to go to my next thing, talking about manual stations. And I think, a lot of times when you're talking to Rockwell and the other big automation vendors, even if it's a totally manual station, maybe there's a couple buttons they have to press and some things they got to scan. The answer is to put a PLC in there. It sounds like with
Right.
your, it's like, I really don't need a PLC for this.
Yeah.
So it sounds like your edge device has some I/O in it, and you can take in a scanner, you can take in other devices, you could probably take in some clickety-clack contacts as well, and maybe turn on
Yep.
some lights.
Yep. Oh yeah, we have output, input. We have. I mean, we use the Raspberry Pi based microcontroller. Our secret sauce is the software that it took to make them 5 nines reliable, which was a trick, but because no one cares why that factory goes down, right? If it's the
Yeah.
barcode scanner that didn't work, it's still down, and we have to
Yeah.
fix that level of reliability. But it has that. We have the ability to add in other I/O modules, right? That can
Okay.
communicate with either our server directly or through that. So you can go, or you can go to a PLC. Like
Yep.
the PLC is still really great in a lot of applications. But to your point, if you want to read a $18 Amazon special pressure transducer for just to know the airline is in range of the pneumatic tool, seems a little wasteful to put a PLC in place with an I/O block to grab that when I can do it with a $50 piece of hardware. And same regard, using the Pi as a safety critical motion system controller is probably not a really good idea for you. But we just want to give the right tool for the job as an opportunity, and then to solve the real problems. So you mentioned mixed automation and manual, which is the way of the world, frankly. There's always a human being somewhere. If you can find that lights out factory that isn't making like semiconductors, I'm interested in seeing it. But what, battery manufacturing, I'll use that because we bump into that a lot. It's a hot topic in some circles.
Sure.
You've got these automated cells, but you still need to record the epoxy lock code. For instance, it's going into the dispense system. So you change out a 55-gallon drum, there's a human being that did that. You're going to put in all the effort to have a fixed barcode reader on there and a rotating system to get the drum in the right location, and then an arbitrary pick your backup system when the drum got scratched and the barcode can't be read and it's down to, so you got a camera for the human readable. Like, to automate that doesn't make any sense when you can have the person who dropped it off go beep with a $60 scan tool. So it's that blending things together that I think is a really interesting piece. The more automation you have, the less the MES is kind of needed. Frankly, we get cheaper and cheaper the more things automate. But it's about filling that gap. And then we talk about data next, which is the other side of the house. But the automation creates all that information. So
I think we've already discussed this really, but I really wanted to circle back to this. So, like you said, starting a company is a lot of work, and developing a platform from scratch is a lot of work. And you would never want to do that again. But you did this, and I know we kind of already touched on this a little bit, but I really want to circle back to it. We this is a massive undertaking, right? And so, what was, if we just go over this again, what was the main drivers for you taking on this massive thing to create a new MES that's going to, for once and all, just do it right?
Yeah, I mean, to me, there were two key weak points when we started Pico that I wanted to attack. One, the ability to airproof your processes in 5-minute changes. I'm not talking about having to write, a new driver because you want to bring in a random scale. Like, how do I have this massive, engineer's toolbox to allow me to have a problem bubble up in the morning, whatever happened, crap, we had there was a chance for a human to cause a mistake, or the automation system was allowing something to get through. I don't want to deal with that ever again. I want a clean cut in a repetitive environment. Like, how do I block that? So being able to do that has always been possible, but being able to do it quickly and efficiently is the challenge. Like, when I was at GM, you know how many days it takes to get another torque tool put online? Like, it's insane. We can input tools in literally in 5 minutes. You plug it in, it auto identifies if it has a system that communicates. If it's a printer, you might have to create a template. DC torque tools are under an hour, and the majority of the time is to set up the rundown process. Like, it's taking out all of that wasted energy so that people on the plant floor can solve the problem quickly. That was number one pet peeve. And then number two pet peeve for me is the access to the data. I call it the difference between thinking and knowing, right? You think you have a good thought on how you built something, but if you don't have data to prove it, you don't know. I don't care who you are. Like, the ability to have that data trail drive continuous improvements, it's an addiction that once you've had it, you can never let go of. The ability to go, oh, let me pull up this serial number and see here's exactly the produce consume chain. It went through this subassembly into here, into here. Here is every piece of information collected. There's not a go into another system to get the torque data and go into another system to figure out what the voltage read on the cells coming into the module were, and a different system that tells me, oh, I got to go into the dispense system now to figure out the lock code that's inside of it. Like, that stuff slows down progress. And when you're in a complex industry like aerospace or automotive, that matters, right? If it takes you 2 days to solve an issue, 2 days would be great, first of all. But if you can solve it in 2 hours, you can solve so many more things when 80% of your day is meetings and firefighting, right? Like, and it was about having systems that allowed that to happen.
Sure, and that kind of brings me to, like, are you relying on other people to collect and store the data, or do you grab, like, for, let's take ignition, for example, are you using their data that they collect, or are you actually taking, look, I need this data in my system separately? So how does that work? Do you
It's
store
the
everything in your own system, or?
Yeah, it's the user's choice. So we look at ourselves as an aggregation option. So uh, and our focus is on being able to make sure any factory can do this. A 20-person
Okay.
factory, it's a tier 4 supplier, or building a little widget that they sell commercially, or a 1,500-person facility, right? Everything in between. In the past, this type of technology was limited just to that bigger size facility that could afford the really expensive deployments. But inside of that world, then you give the user a choice.
But before we get into that, I want to thank theautomationschool.com for sponsoring this episode of the show. That's where you'll find all of my online courses on Allen Bradley and Siemens PLCs and HMIs. So if you know anybody who needs to get up to speed on those products, please mention theautomationschool.com to them. And now let's jump back into the show.
So if you have automation in place and it's already connecting, I'll go back to the battery example. It has voltage measurements and barcode reads on the cells, and maybe it does a high pot test on the module, and there's like an image capture. We can grab that from the automation system and tie it to the downstream systems that are manually assembling the battery pack, for example, right? Because
Mhm.
it's hard to automate those pieces
Yep.
of the puzzle, especially in high configs. And that way, there's not a data silo problem in there. If they haven't built the automation yet, and for some reason the automation company has a hard time figuring out how to connect to one of those devices, you can insert Pico, it'll connect to the device, and then it'll tell the SCADA as if it was a PLC when triggered what the value is on that, or to kick off a routine. We can run Python scripts for flashing firmware, for example, something that's
Mhm.
possible to do in automation, but it's just really easy for us to do. So save yourself a few $1,000s, and it's just part of that deployment. So that's the more sophisticated route. When people have been through it once or twice, they can start mixing and matching who's good at what, knowing that all the systems are integrated and they'll play nice together. But that's how I see it, is it's giving options. If you speak ladder logic and that's the only logic you want to know, and you want to go in and everything's a PLC and program to it, great, no problem. We can fetch a CSV file you generate and parse it into variables on our side and run dashboards and SPC charts against it, or create a report that's the full traceability required by the US Navy for the thing you made, or whatever it might be. Like, why ask the automation system to do that kind of work if we can do it more efficiently? So, and then in the same regards, we don't do time sequence data. We're the shit, frankly. Sorry, my language. Like, we really good at events. We're really poor at time sequence versus the PLC, where it can watch a variable over an alarm when it goes out of sequence and things like that. So marry the two. What a great marriage, right? That's doing this. The alarm goes off. We take that alarm trigger. We already have connections into Microsoft Teams or into Slack if you use that, or email or
Mhm.
text. And now the automation company didn't have to figure out how to do all of that stuff.
Yeah.
So anyway, that's the vision, is you can just solve a problem without having to create code.
Now, I think let's talk about and that makes a lot of sense to me. Let's talk about what your customers see. So they have a Pico MES system. Like, are there different views for different type of people? Who sees what? And I know every deployment can
Yeah.
be unique, right? But explain some of, like, in one of your more favorite, I guess, applications you guys worked on. Talk about the different views people have. Like, I'm sure you have somebody who's like higher up on the food chain, maybe up in the front office, who needs a view, and then you have people on the plant floor. They want to know. Maybe they got OEE. They gotta get their act together, or else the line's going to be shipped overseas, or maybe there's a bonus tied to getting keeping quality, or cutting scrap. So talk about the different views, because I know your system does a lot, through code, but it also has to interface with people, right?
That's right. We have four key customers, if you want to think of it that way,
Okay.
in the factory. So the first one is the operator doing the work. So we have it's a work instruction visualization or worker guidance suite. So similar to an HMI, but it's moving step by step as they are moving. So you scan a barcode, it accepts it. If the pattern match works, it'll automatically advance forward. The operator doesn't have to do anything. And now out of the corner of their eye, they see a visual representation of the next step, image, video, CAD screenshot, whatever that might be. There's text, there's layered content, there's a training kind of side of the house there where more information is available in certain situations. And then the layer above the person doing work, or say, on the machine side of the house, you would just use the HMI. So you wouldn't need that view.
Okay.
The next layer up, though, is the supervisor. So they're going, okay, now I want to look across multiple stations and know who's on pace, who's not on pace, who's having trouble, what's working well, where are my issues. It's basically a reacting type role, right? I react to wherever the problem
Sure.
is.
Yeah.
And so they get a view we call it a TV view, but basically it's the classic, 5 colors of station status. If they're on pace and there's no alarms going, it's green. If they're falling behind pace, it might go yellow. If they have a machine issue or a person is having a trouble, it goes red. But that's their item. They also can interact with we interact with teams and these kind of shared comms, so they could be following on their phone whether or not an alert occurred or a quality defect, and it'll ping them
Sure.
when things are happening. Then you go a level up to the engineer. So now their view is in the background for a lot of it. They're setting up the work instructions. They're setting up the device connections. They might be looking at the data to go down a Kaizen project and they're looking at cycle time data and how can I rebalance it. So their views are in what we call the manage pages, sitting in the background. They have access to all the other views as well, but they might be focused on the setup and the data side of the granular data. And then the final is the executive view. And now there's arts and charts, as we lovingly call them, for what did I make today? What did I pay people? What did I get for paying people effectively? So you have your output run rate charts by part number or product number. You've got OEE over on the station level side of the house or equivalents. You've got maybe standard reports they want to see. So like we send in this work order, when was it completed? Some of that comes out of the ERP, some of it would come out of Pico, depending on how they set it up. But it's much more of the strategy. And then typically they're going a level, it's like a Venn diagram. Everybody overlaps at least one level. So the executives might be looking at one level down data to understand, what's our capacity? Do we need to buy more equipment? Run overtime, add a shift? Like, where are we relative to that? If I improved these perennial problems, could I save that equipment purchase? It's a really common question. If I get an order for 15% more, am I buying equipment or can I find 15% in my processes? Well, at least we can tell you what your losses are. The engineers are looking at, the engineers know you get to do your job right up until the moment something goes wrong. And then you stop and you put on your firefighter hat, you walk out to the line, and now it's problem solving time. So they're watching the TV view like everybody else or the connected channels. So, but that's how we see the world, is kind of in these areas. You notice the roles that Pico didn't directly interact with. I didn't mention the electricians or the technicians or the maintenance crews, right? They have opportunity if they wanted to use us for maybe the work instructions associated with PM on a machine. But there's other systems out there that work really well for that. So if you want to use MaintainX or Limble or pick your flavor of ice cream for PM CMMS, well, we integrate with them. So, one of the manually done tools, like a DC nut runner has a problem, the operator can trigger a ticket for maintenance into that, or we can do it based on number of rundowns for standard calibration cycles. But that way, we can interact with their world, but they can live in the world that works really well for the CNC machines that they're operating, or the injection molding machines, or whatever, the automation equipment. Let them stay in their world. Same thing with the ERP. We connect into the ERP so the accountants get the information they need. Right? They need to know how much labor they put into those parts so that they can write it off for taxes. Right? How much scrap happened, taxes. There's things like that need to go back and forth. So the key for us is making those integrations as easy as possible.
Yeah, and scrap definitely, depending on where it happens in the process, could be cheap or very expensive.
That's right. Add a bunch of labor content or parts on the other end of it, and tear it back down again. So but the goal, when I think of this whole thing, it's trying to just let people, get out of their island
Mhm.
Every one of those views, whether it's the engineers creating the automation, and the engineers setting up the processes, the operators, the execs, they have their island. But if they can't see the world around them,
Hey everyone, I just wanted to jump in here and pay some bills. Thank you, first of all, for listening to this episode. And while today's vendor wasn't able to sponsor this episode, I still wanted to invest the time to bring it to you because I think you're like me. You like to learn about new products and technologies. So, with all that said, I'd like to ask you to consider becoming a member for just $10 a month, either on YouTube or at theautomationblog.com, to help me offset the cost of producing these episodes each week. In exchange for your membership, you will receive member-only perks and ad-free editions of every unsponsored episode of this show. With that said, thanks again for tuning in this week, and now we'll return you to this week's episode.
then the factory can't win. And I would argue one of our things we're doing is by making this technology available to the supply base, to the smaller factories, you're actually able to go outside of the four walls now, and you could, in theory, transfer data across suppliers, and the whole supply chain for a complex assembly can now collaborate or improve. Or there's circularity of scrap. There's matching A, B, and C bearings with A, B, and C rotor shafts, right, for tolerance stack ups
Yeah,
and things like
yeah.
that. So, but you need a digital backbone for that. You can't do that with Excel and paper. It's too delayed. So being able to build these solutions for each one of those views, but in a way that it structures, that was always the goal of that ISO 95 pyramid. I'm gonna come back to the beginning, right? Is everything's available, or unified namespaces after the same target. But then you put that across multiple factories and things start to get really interesting. And that's what Pico is really unique about. Our data model is the same for every factory we deploy into. So we have tools that can cross factories. It's the next generation.
Yeah,
So
very important too. And I know plants, factories compete, especially there's a lot of companies that have multiple plants all over the U.S. and they compete heavily. A lot of times it's shown as a failure if plant X cannot provide products and plant Y gets to provide the product to plant X's typical customers. And so they compete internally very, very heavily because they don't want to be, if there's a downturn, the weakest has to be called, and they always want to be at the top. They want to be not only getting the bonuses and giving the people, that assurance that their job's stable, but also is that internal plant versus plant versus plant. And a lot of companies, they're vying to beat each other and be the most efficient and most productive facility in around, even with things as simple as aluminum cans that we drink our beverages out of. I mean, it's very competitive.
yeah,
So, what are some of the things like a prospective customer comes to you? What are the kind of things that you want to hear from them or you want to ask them to know if they're a good fit for Pico MES?
yeah. So for us, the first thing right out of the bat is the type of work being performed. Right? Are you making things? Or are you making things that contain things, right? Or whatever the classic process versus discrete.
Sure,
So
sure.
we focus on the discrete side of the house, and with an assembly flavor. There should be people involved. And if you're heavily automated, we're still happy to work with the team. Most of our factories are a mix of manual and automation. Um, but that's the first kind of scheme is does it fit what we do, which is guide people, tie into tools and equipment for error proofing data collection, and then use the data for value. And then from there, it's really what is the pain of a mistake is a good way to think of it, right? If you make one thing, if you're a job shop that takes one order, makes one part, and may never see it again, to invest in infrastructure to ensure that one part, you should be investing in quoting software and
Yeah.
workflow management software. There's better stuff out there than that. If you have a fleet of CNC machines and you're just wanting to monitor those to have the highest OEE, there's better, like we can do some of that, but there's way better software out there that does that. So we tend to push people that way and kind of help them find. But for us, sweet spot, you're assembling something, ideally in the US, and then you have some amount of repetitive nature, either consistent processes that make lots of things,
Mhm.
or make the same thing over and over again. So
Yeah, we go ahead.
I was gonna say automotive and aerospace and industrial equipment are our sweet spots today.
Yeah, I think you did a good job explaining that. And I was kind of thinking S88, right? So this is not a batching package. There's a lot of similarities, equipment arbitration and
Mhm.
but batching gets into recipe handling and there is some of that here, but and there's a lot of similarities, but process automation is different on many levels. And I can see why, given the kind of information and the kind of customers you've talked about, why you'd be talking more about manufacturing, like discrete manufacturing, making products. And I think that's what most, like, in my world of PLCs, HMIs, and SCADA, that's what most facilities are doing. But, you also have it in utilities, you have it in process. But most of the people I meet and train, they're in manufacturing. They're making products, whether it's an aluminum can or it's something very. And there is even some extruded products that would, I think, fit very well
Mhm.
because they run it like it's not really a batch. Even though they run they're running a product like, let's say, making a sheet of plastic. It to me, it always seems to have more in common with you know. Um, discrete manufacturing. It's like making a very long bumper for a car. You know what I'm saying? Versus making 50,000 gallon tank of some kind of a paint or thinner or something. Very much different process because that's actually going to be pumped somewhere at the end of the day and not actually cut up and sold as pieces, right? So
I like to describe it as beer versus gaskets. I know it's kind of an interesting combo, but
yeah,
like
yeah,
when you make and the other thing I mentioned to people is like you could make a system like ours work in those other environments, just like you could probably take an OSI Pi system or equivalent and get it to work on certain discrete applications, or take Ignition and try to make it into worker guidance. It's the pain involved in doing it.
yeah,
That's what you're just that's all we're sorting for, is to try to make the cost as low as possible and the speed at which you can deploy, which is another version of cost, um, as rapid as possible. So, could we make beer work? Sure. But like if you think about where our edge really lies, it's like a gasket. So gaskets are, you have a slurry process, and then it might come out onto a sheet conveyor,
yeah,
go through an oven, there's a slicer, and then there's the former. And at the end, it's cranking out individual pieces. And
yeah,
especially companies that take that little piece and put it into a higher level assembly, now you're talking.
yeah,
But can we run that line? Sure. Yeah, we know how to talk to scales and things like that. And we can set alarms. It's just not as great of a fit as another system that's designed specifically for that kind of time sequence flow of material through a pipe. Uh, and there's everything overlaps. Like this is why I think it's
yeah,
hilarious
yeah.
that people get into the weeds of like, oh, you're this niche, and I'm like, I wish I could just have that niche because it would make my sales life infinitely easier. But the reality of it is that everything kind of overlaps, and it's
Yes.
my
Yeah.
niche centers around there. But yeah, anyway, because you think about our connected supply chain comments, if we want to make the corner assembly that's going into the truck plant, right? So it's got an upper lower control arm and a knuckle and a brake and a rotor and a
Yeah.
caliper, all of
Yeah.
that, right? Classic assembly.
Yeah.
Well, then you need if you're going to have the information of that whole corner be available to Ford, you need to be able to go into the system that was machining and assembling the bushings into the control arm. And then you got to get into the casting house that made the thing in the
Yeah.
first place, right?
Yeah.
Otherwise, you lose that data through the
Yeah.
system, and now something goes wrong. You don't know if it's because the casting was wrong, the machine part was wrong. Like pick your flavor of ice cream on where the problem might be. So there's flexibility that allows these to come together. And then more importantly, I call it the don't be an a-hole thing, but it's like if somebody came to us and was like, hey, we want you to run our state of the art casting facility, I would say that's probably a bad idea. Like, don't be an a-hole and help them find the right solution. But
Yeah.
when it comes to that assembly of the control arm, yeah, we're really good at that.
Can you give us some
Autom-
other examples that you've
yeah,
worked on with some of your customers? Those were good ones,
sure.
but I was just thinking maybe throw some others out.
Yeah, we have, so the automotive example is one. We make a lot of complex industrial equipment. So think
Okay.
like switch gears that go into data centers, like all the
Yeah.
electrical cabinetry for power generation and backups. Those are really complicated. You can't memorize that process. And
Hmm.
then making an error is really expensive because you got to tear down a lot to be able to fix it. Vehicles clearly come into our world, whether it's a tugger all the way or a fork truck into RVs. We have legs into full-on automotive plants, things like that. You can use this as a piece of the puzzle. We sit alongside traditional MES systems, and we're just a worker guidance tool. We have other companies that actually don't use the worker guidance part and just use the tool connection part. So there's just a trigger and response system.
Okay.
And then you get access to our huge library of manually actuated tools. And then what are some other fun ones? We've got a lot of battery manufacturing, especially 2-3 years ago when that was really spooling up. We had a lot of plants come online. Semiconductor equipment. That's another example of the people inspecting wafers or doing parts of the process with the photo. I forget the name of it, but we shine the photo and it makes the system. There's all those motion controls inside of there that are just extreme tolerances inside of really complicated assemblies. We have a good strong footprint in there. We spooled up boats are a fun one. You want to know how a pontoon boat is made? That's really interesting. I'll give you a hint. It's not automated. And then some other fun ones. We have high mix like sensors and valves for oil and gas. So you can imagine, think about all the part numbers you can order for proximity sensors in different configurations and housings and all of that. Now put a layer of safety on top where they're rated for harsh environments like that. Now you can't have an error and you have this crazy high mix and you have to label it and have all of this certification paperwork. So we help manage that significantly. But I'd say over half our business is automotive and aerospace suppliers. And then the other half is these kind of random industrial things. We do have one process factory. It's a former user who went to a process factory and is like, I can use you here.
I can make it work.
Perfect. Yeah, he's got a SCADA network for everything else, and he just uses us for the sampling systems. So, which makes total sense, right? You get our whole IoT network, and so we connect into the SCADA networks for the data silo problem and nothing else. We're just fetching files and bringing it into the historian, and then you can tie all the inspection systems together. So the scales that measure the, what was the dispensed component amount? Our camera systems that we can deploy for, was the slurry applied properly? Environmental sensors, all that fun stuff. So.
And that is a place a lot of times where the automation guys struggle because it's very expensive to try to automate that with a PLC.
I mean, you can deploy Pico for trivial amounts of money. You can even deploy it now. We released a free, what they call a freemium model. So there's a free version of work instructions for up to 10 stations. You can add a paid user license to unlock all the digital tools for $100 a month. And then you can go to a connected station. So in theory, if you just had one user and one connected station to do that inspection, you're looking at $200 a month. You could reach out to us if you needed a one-time buy, so you didn't have to deal with recurring charges. So why on earth would you go through it for the less than the cost of the PLC? Here's 5 years of Pico, right? And you didn't have to wait. What's the current lead time on Allen Bradley's, right? Are they finally down from 9 months or whatever they were at a year ago?
I don't know. I haven't had them on the show.
No comment.
No, I don't. I literally don't know. I mean, I used to. I don't anymore though. Well, but I think, and that's true. Would you say? Go ahead.
It's just an easy way to supplement a bigger system. That's what we mean by modularity.
We have some listeners who are struggling with that, kind of like those manual systems where they have, people have to do some manual assembly or manual setup, and they're struggling. They're like, doesn't fit what a PLC does. I mean, is that a good customer for you to contact you and say, look, we do a lot of stuff, but we're really good at this. This is one place we're really good at. And we can tie into your existing PLCs and HMIs, but we can take over those stations, those operator stations where they're doing some assembly, and you're not capturing that data right now. Or am I off on that?
No, it's a great application, and what I like about it is we get really lightweight and really low cost at that point. So because we're not trying to drive the entire thing. We can be just a little piece in the puzzle. Just think of us as instead of buying a Keon sensor, you bought a Pico manual station control
Yeah.
system
Yeah.
for that. And then what I like about this is it doesn't matter to me where the data historian is as long as there's a single source of truth and it's all in one spot. So if you
Yeah.
want me to feed whatever happened in the manual world at build complete into the automation system, then we just set up the communications to do that. You can use the same comm structure in all your different locations, or we feed a common database that effectively becomes a unified namespace if you insert lots of details. But it's a neat tool that now those teams can bring to bear. What we typically find is actually the opposite, where the automation company is like, I just want to do my little sweet spot, or the automation engineer. I'm really good at this. I can do the motion and the pick and the place and the testing and
Yep. Yep.
the value add. And I don't want to figure out what the hell you're doing over here in manual world. And in
Yeah.
which case, then they go, here's how this works. You should buy a system like Pico or one of the others that
Yep.
I mean, pick your flavor of one you'll hate more. But then we just tie you into us, and the user has that kind of flexibility. They have
Yeah.
to learn. It's a very minor software set inside of Pico to learn. It's not like this is months of training; it's hours of training,
Mhm.
because they're not trying to get into the craziness. So
Yeah.
at that point, now they can see the automation data, they can see the manual data, and they're happy.
Well, I see that
So
use case. I can definitely see that use case. I think another use case, tell me if I'm wrong, but you have these small to medium sized manufacturers that they always knew they needed an MES system. They need some KPIs, they need some OEE, they have some manual stations they want to track, and they just there's no way in God's green earth they're going to get a $10 million, capital project approved for MES, right? And so they've always just said, is that a type of customer that would be a good target as well? Because I know so many people never do the projects because the price just goes, through the roof. It's millions and millions of dollars.
yeah, that's our sweet spot. That's what we built the company for, is
Okay.
for small and mid-sized factories. We know we can go up to the bigger factories and do
Sure,
from
sure.
time to time because it pushes the technology. But 90% of our customer base is small and mid-sized by definition, 500 people or less. The real sweet spot's between 100 and 200 people inside of the factory, right? No one's going to touch that typically
Yeah.
in the MES space. And what we do is we give them. That's part of the reason why you have that whole lower pyramid. Is an MES by itself is effectively useless, frankly, if you can't tie it into data structures that are feeding it good information. So it's giving them that whole system as a place to start. And with us, you can start for the $100 a month is like a trial. Yes, in
Sure. Oh,
theory, you could
absolutely.
start there, but it is. We have a significant customer base that's at $12,000 a year, 12K total, and they just run the digital tools. They care about traceability and worker guidance. So think
Yep.
the value props are training reduction, always the right process on the screen at the right time, and the ability to say this is when the part went through. So it's not error proofed, but it has all the traceability. So if your process or your product is error proofed, great application, low cost. Aerospace suppliers love this because they can run local, which means then you get ITAR certification, right? So we can run in the cloud or local, which is kind of nice. And then I'd say our most common customer is the one that blends in the error proofing. So this is where the ACV or annual contract values get into the 40 to 50K range, and we're governing probably 20 to 30 million dollars worth of product creation, maybe more, depending on whether they're selling a widget or they're selling a finished good with a higher markup. So round off error in the value prop. I mean, we'll move you
Yeah.
30% in output.
You're either
Same
going to
same
take,
amount of equipment.
you're either going to get data you never had, or you're going to be taking busy work off of a lot of people's shoulders. Because without a system like this, there's a lot of people trying to do busy work, or people just don't want to do it, so it doesn't get done. So you don't get that traceability, you don't get that information. And
I mean, there's
so,
three.
yeah, go ahead.
There's three value props you just point to just every time. So just measuring something that wasn't measured before and giving the operator feedback, just giving them basic feedback on how they did, you're going to get anywhere from 5 to 15% output increase. And there's a little gamification that occurs. Not everyone will move, but the mean will move up that much. You go put in error proofing in the continuous data flow. So just being able to, the traceability data says how long it took me to build it and where my errors are. You'll go find 1% improvements 20 times. You'd be shocked. It's very rare you go into a factory and there's a 20% hand grenade sitting there. Oh man, if I had known not to do that, I could increase my output 20%, right? People aren't stupid, but they can't see 1% failures that are occurring randomly throughout the factory. Well, with our world, you can, and more importantly, you can stop them. That's where the tool connections become very important. So you gain another 20% there, right? The range officially that we state is anywhere from 15 to 50% increase in the number of parts produced for unit labor. Right now, I don't know your factory. If it's running and having a hard time, you're going to be up towards the 50%. If you have a really strong factory, you're going to be down in that lower section. If it's heavily automated, it's probably less than that. But what we can guarantee you is you will find the gains that you didn't know existed, and the pricing aligns to the value. Right? You don't spend a lot of money if you weren't gaining a lot of things. Right? The way the whole structure of selling by the station. So to me, it's just. That's the one thing I hope people realize is in the past, expensive, difficult to roll out. You're going to be held back by it. It's going to cause lack of flexibility in your factory. Arguably what happened with automation too, right? What's modern world look like now? Flexible, easy to readapt around a change in your business system. It generates data that drives insight that has increased value over time because you're able to continuously improve and find things over there. And it's modular. You can now get a Click PLC for $300, right? Like you're not spending.
You can get Rockwell and Siemens PLCs for $300 too. I mean, almost every vendor. Yeah, you can, and that's the problem because if you go with a big house, they're going to want to use the $50,000 PLC.
I just mean there's options. There's just choice.
There's lots of options. Yeah.
Yeah.
Well,
that's that can be an issue in itself, but.
Yeah, you go back like if I want to buy, and I'll just say brand X, MES. They're going to probably want me to have the Cadillac of every other product they have, and that doubles the price. It's like, I really don't need that. I really don't need the Cadillac. You actually make, you make compact cars too. Those work well, if you're not, for the use case. But, well, I guess the last question, go ahead. No, go ahead.
I was just giving him a choice. That's all. And then walking him through the path, don't be the a-hole philosophy, right? Like, help them through their choice, whether it's to you or to somebody else.
Yeah, absolutely. So I guess my last question is if any of the audience out there, we have the best audience in industrial automation, if any of them say, we should look at this, like who would they contact to maybe do like a Teams or a WebEx or, a Zoom call to learn more about what you guys do?
Yeah, we're a put up or shut up kind of a house. So if you go to our website, there's a request demo form that'll allow you to ping, and we'll reach out from our teams or our side of the house to set up that call. So we'll ask you a couple questions so we don't waste your time and show you something you're not interested in. Then we can set up a live demo and literally walk through the MES. But the other side of the house is you could sign up for the product and play with the work instruction side of the house and the digital tools for free. And then that way you're not just listening to me about what it's like, you can actually experience it for yourself. There's also a boatload of YouTube videos and things like that too.
So, and I just want to jump in here and say, for those people walking the dog or, driving home during their busy commute, could you give them your website URL?
Yes. Yeah, it's picomes.com. So PICOMES.com. Yeah.
Super easy. You can't get better than that. Well, Ryan, I want to thank you for coming on the show. I really enjoyed talking MES. I haven't talked MES in a while, and talking ISA 95 and all this stuff. And I do think there's a lot of smaller factories out there that can use a product like yours. So I really want to thank you for coming on the show.
Thanks for having me, Shawn. And sorry for the rabbit holes of going into, but it was really fun. I enjoy the kind of back and forth like this. So. And for anyone listening, if you want to get into the weeds on the technical conversation, I'm available on LinkedIn. You can find me there, or just reach out to Pico and they know how to get a hold of me. But I love having these kind of conversations too.
Well, I hope you guys enjoyed that episode, and I want to thank Ryan for coming on the show, and I want to thank our members who made the video edition of this episode possible. You will find the video edition in the members-only areas on both YouTube and on the automationblog.com. So thank you to our members for supporting the work we do here at Insights in Automation. And with that, I again want to wish you all an awesome Thanksgiving weekend. Hopefully you get all 4 days off. And I just want to wish you all good health and happiness. And until next time, my friends, peace.